Hi, in this video we're going to continue our discussion on integers, and in this case we're going to look at the different operations that we can do with integers. So integers support all the standard arithmetic operations that we're used to, like addition, subtraction, multiplication, division, and even exponents, using this double star notation. But what is the resulting type of each operation is something that we should ask ourselves. In other words, if we add two integers, what do we get back? Well, we get an integer back. That kind of makes sense. 3 plus 4 is 7. They're both integers. 7 is an integer. That's fine. And subtraction will work the same way. Multiplication will work the same way. If you multiply two ints, you get an int back. And if if you take the exponent of one int with another, again, you'll get an integer back. 2 to the power of 2 is 4, which, they're all integers. So that kind of makes sense. But division is a little bit different. Division will always return a float. Now, it's pretty obvious when we do something like 3 divided by 4, right? That's 0.75. So we can't expect 0.75 to be an integer data type. It's going to have to be a float, which is what Python will return. But maybe not so obvious is that if you do 10 divided by 2, well, yes, the answer is 5. Technically, it's an integral number, but it will still get returned as a float type. And we'll see that in the code section. So division will always return a float. So that gets us to two more operators that we have when we're dealing with integers. So first, let's take a look back to long division. We can remember that from our grade school. And that's when you wanted to divide, you had a fraction like 155 over 4, and you did long division on that. At that time, you didn't have a concept of a decimal point and numbers after the decimal point. Everything was working with integers. So let's take a look at that. Right, so first, just some terminology. This top number here is called the numerator. The bottom here is called the denominator. So we're going to take 155 divided by 4, and we're going to take that long division approach. So 4 goes into 15 3 times, so that's 12. So that leaves us with 3. Bring down the 5, we have 35. Once more, 4 goes into 35 at most 8 times, which is a value of 32. We're left with 3, and 4 doesn't go into 3. That's it. We're done with the long division. And so we would write down our answer and say, well, 155 divided by 4 is 38 with remainder 3. So we can also put it another way. And this is going to be the more important way of rephrasing this statement here, which is that 155 is 4 times 38 plus 3. So 155, right, is 4 times this number 38 plus the remainder. So we're going to give this a name. Essentially, we're going to say we're going to define some operator that we denote by a double slash, so double division. 155 / 4, that will return that number 38. And we're going to define another operator, this percent sign here, so 155% 4 will return that remainder term. So if we use that notation, then we get that 155 is 4 times this expression here plus this expression here. This expression will evaluate to 38, and this one will evaluate to 3. Okay, so 4 times 38 plus 3, we get 155 back. So this operator here is called the floor division, which I'm just going to say div for short. But it's it's an integer division, but more specifically, it's a floor division. Right? That's the name of that operation. And this operation here, this operator here is called the modulo operator, which I'll just shorten usually as mod. So we'll have div and mod as these two operators, / and that percent sign. And the thing is about these two operators that they always satisfy, well, exactly that equation that we saw here. So in general, they always satisfy this equation, where n means the numerator and d means the denominator. So we have the numerator, like 155, is equal to d, the denominator, like 4 in this case, times n div d, 155 div 4, plus n mod d, 155 mod 4. So this is an important equation because that will come back again and again as we discuss the div and the mod operators. So first, what is floor division exactly? What do we mean by floor division, right? We gave it a name, we gave it a symbol, but what is it exactly? Well, first we have to define what the floor of a number is, and we can take the floor of any real number, right? It's not necessarily of an integer. So the floor of a real number a is the largest integer less than or equal to a. And that's really important to understand that, and you'll see why in a bit. But it is the largest in the standard number order, right? So if you draw out a number line, then you look at the number on the number line and you find the largest, which means to the left of it, the largest number less than, the largest integer number less than or equal to the number you're looking at, okay? So for example, the floor of 3.14, well, the largest integer less than 3.14 is 3. Same thing with 1.9999. The largest integer less than 1.9999 is 1. Okay. The floor of 2, well, it's 2, right? Because the largest integer less than or equal to 2 is 2 itself. But watch out for negative numbers. This is where this definition is important. What's the floor of minus 3.1? Well, you might be tempted to say, well, it's minus 3, right? We're truncating here. We're just taking the integer portion of the number and throwing away the decimal points, or what comes after the decimal point. That's not quite how it works. Let's look at a number line, right? Here's our number line. Here's negative 4, and here's negative 3. And the number that we're interested in is minus 3.1. That's between those two values. Now, if we look at the definition again of floor, it is the largest integer less than or equal to a. Well, what's the largest integer less than minus 3.1? It's minus 4. It's not minus 3. Minus 3 is greater than minus 3.1. So minus 4 is in fact the floor of minus 3.1. So that's an important distinction. Floor is not the same thing as truncation. It is the same when you're dealing with positive numbers, but not with negative numbers. And that has an impact on the mod operator that we saw. So we get to our definition of floor division. A div b is the floor of a divided by b, right? So if you get some a divided by b that gives you minus 3.1 as a result, then you take the floor, which will be negative 4, and you will get minus 4 as your floor. Now, let's look back at that formula again, right? Remember that formula that we wrote down, that we said, now I'm not using n's and d's anymore, it doesn't really matter. Let's look at an example. Let's take a to be 135 and b equal to 4. So 135 divided by 4 is 33.75, or 33 3/4. Right? So in other words, if we did long division, we would say 135 divided by 4 is 33 with a remainder of 3. So 135 div 4 is 33, right? Because 33.75 floor is 33. 135 mod 4 turns out to be 3, that remainder that we had. And in fact, if we look at this equation again, and I'll bring up that equation many times, then we have 4 times 135 div 4 plus 135 mod 4, right? 4 being that denominator over here. So we get it's 4 times 33 plus 3, which is 132 plus 3, which is 135, which is indeed equal to a. So now let's deal with negative numbers. This is where things get a little crazy. So again, I want to reiterate, a div b is not the integer portion of a divided by b. It is not the truncation of a divided by b. It is the floor of a divided by b. Now, if a and b are both greater than 0, then yeah, it is the same thing. But not when we're dealing with negative numbers. So let's take a look at an example. Let's say a is minus 135, negative 135, and b is 4. So same as before, except we've made a negative. So now if we do the division, well, that's minus 33.75. So, we might say it's minus 33 3/4. So minus 135 divided by 4 in div, right? Minus 135 divided by 4 is minus 33.75, but the div is the floor of that. The floor of this number is negative 34. Compare that to when we had 135 div 4, which was 33. Okay, so already we see there's a difference in the div value. What about the mod? When we say minus 135 mod 4, we get a 1, whereas before we got a 3. Now remember that the mod is not the remainder, right? In the sense that it's not 3. It's just something that has to satisfy that equation that we've talked about, and then I'll keep bringing up again and again. The div and mod operators are defined and calculated in such a way that this equation here always holds. So let's check. Let's make sure it holds in this case. Well, we have 4, right? The b was 4 times minus 135 div 4 plus minus 135 mod 4. So if we do that calculation here, we have 4 times minus 34 plus 1. And so we get minus 136 plus 1, which is minus 135. And that matches the minus 135. So as you can see, that's how the div and mod operators work. And they work in such a way that that equation is always satisfied. So let's expand this a little further. Let's take a equal to 13 and b equal to 4. Well, 13 divided by 4 is 3.25. Now let's take a equal to negative 13 and b equal to still 4. So now we've just made a negative. Well, minus 13 divided by 4 is minus 3.25. Let's take a look at when we stick the negative sign, not with a, but with b. So we leave a at 13 and we make b equal to negative 4. Then 13 divided by negative 4 is still minus 3.25, right? When we do regular division, it doesn't matter if you put the negative sign, in the numerator or in the denominator. And lastly, let's look at when both of them have a negative sign. Now we know that when we do regular division, the negative signs cancel out, and in fact it's still a positive 3.25, just like we had here. Okay, now let's look at the div, right? Well, the div of 13 and 4 is 3, right? 4 goes into 13 3 times, this, so it's going to be 3.25's floor, which is 3. Here, the div is going to be the floor of minus 3.25, which is going to be minus 4. What about the div here? Well, same thing. It's going to be the floor of minus 3.25, which is negative 4. And here, the div is going to be the floor of 3.25, which gets us back to 3. So as you can see, this looks, this kind of follows the signs that we had with just regular division as well. Now let's look, however, how the mods are affected. Well, 13 mod 4 is 1. Minus 13 mod 4 is actually 3. And we'll see that when we check the equation. 13 mod negative 4 is negative 3. So you'll notice how this mod is basically carrying the sign of the second portion here, right? Of the denominator, if you want to think of it as a fraction. So 13 mod negative 4 is negative 3. And here's another interesting one. Minus 13 mod negative 4 is negative 1. It's carrying the sign of this second one here. And in each of these cases, it satisfies that equation. Let's check. So in the first one, we have 4 times 13 div 4 plus 13 mod 4, which is 12 plus 1, which is 13. So we're good. Right, matched. What about the next one? Well, 4 times minus 13 div 4 plus minus 13 mod 4 is minus 13. It matches our minus 13. We're good. And the same thing here, that matches as well. And lastly, this one here, right, we have minus 4 times minus 13 div minus 4 plus minus 13 mod 4, negative 4. That gives us minus 12 minus 1, which is minus 13. And again, that matches, right? So when you start dealing with negative numbers, it's a little more complicated. You have to be a little careful with that, okay? So now let's look at some code and check all this out. So the first thing we're going to look at is the types when we do these arithmetic operations. So we can look at the type of 1 plus 1, and that gives us an int, right? We expected that. We do 1 times, well, let's do maybe 2 times 3. Type of that is an int. If we look at the type of, let's say, subtraction, let's say 4 minus 10, that's a negative number, but it's still an integer. And same thing with exponents of integer numbers. If we do 3 to the power of 6, well, that type is still an int. Now, division is different. If we do type of 2 divided by 3, well, we would expect that to be a float, right? Because the 2 divided by 3 is, 0.666 recurring, and it is indeed a float. Now, what's more interesting is if we do 10 divided by 2, right? 10 divided by 2 is 5, but the type is still a float. Now, we can print 10 divided by 2, it will print 5.0, right? Now, if we do the actual print, you got to be careful with that. It's going to format it as 5.0. So if you want it to print out as an int, you're going to have to do some formatting. Okay. Now, the next thing we should look at is the floor method. Now, the floor method is in the math module. It's not part of the standard syntax. So we're going to import math, and now we can use the floor. So let's take a look at the floor. 3.15, okay? And as we expect, it's 3, right? If we do math.floor of 3.999999, it's still 3, right? This is not a rounding. It's basically taking the integer portion when we're dealing with positive integers, or positive numbers, I should say. Okay? Now, not so if we're looking at negative numbers. We can look at 3 minus 3.14, and what do we get? Minus 4. That's the floor, right? Now, we can even look at the math.floor of minus 3. Let's say 6 zeros, 1, 2, 3, 4, 5, 6, and 1, right? The floor of that, yes, it's very close to negative 3. And I got to type it correctly. It's still negative 4. Okay? So we are not rounding, we're not truncating, we are taking the floor, the largest integer less than or equal to this value here. Now I want to sidetrack very quickly into something else. Just want to show you that just so you're aware of it, and we'll come back and discuss this later. Let's go ahead and add, I'm going to add 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then a 1. Now we would expect that the floor of that should still be negative 4, right? That's fine. Now let's try this again. And I'm going to put in 3 more zeros. And now the floor is negative 3. What's going on? Well, it has to do with the fact that floats have a limited precision in Python. So minus 3 point, and then here we had 15 zeros and a 1, is actually being represented as minus 3 with zeros, and the 1 gets dropped. Okay, so it has to do with the limited precision that we have with floating point numbers. And we'll get to that in the video on floating points. So just be aware of that. Okay. So now let's look at the floor division operator. So let's take a look at an example. Let's take a equal to 33, b equal to 16. And we're going to print a divided by b. Okay. We're going to print a div b. And we're going to print the floor of a divided by b, right? Which should be equal to a div b. That's the definition. So let's see what results we get. So 33 divided by 16 is 2.0625. A div b is 2, which is the floor of 2.0625. Okay, the largest integer less than or equal to this number here, 2. So in both cases, that works. Now let's just do an example now using a negative number. B equals 16. So we'll keep everything else the same, but just a becomes negative. And we're going to print out the same thing. So I'm going to copy paste. And here's what we get, right? A divided by b is minus 2.0625. A div b is negative 3, right? It is the largest integer less than this number here. Well, the largest integer less than this number is actually negative 3. And of course the floor matches, because that's the definition of floor division. Now I want to compare and contrast truncation, right? So let's look at this one again. So I'm just going to copy and paste this code in here, and we'll look at truncation. And for truncation, we'll print math.trunc a divided by b. And as you can see, the truncation is just giving us the integer portion of this number here. It's basically dropping everything after the decimal point and returning to us just the integer portion of this floating point number, which is -2. So as you can see here, when we're dealing with negative numbers, the floor and the trunc are not the same thing. And so in general, floor and truncation is not the same thing. It is with positive numbers, but in general, you have to include negative numbers. It is not. So just a little caveat. Okay, so let's look at the mod operator. Now, just again, I want to remind you of the equation. A equals B times A div B plus A mod B. Okay, so let's look at some examples of this. Let's say A equals 13 and B equals 4. And we're going to print out the division. So now we've got a few more things. I'm going to actually try and format it a little bit. So 0 divided by 1, well, the positional arguments, equals 2. And we're going to throw in A, B, and A divided by B. Okay. Then we're going to print out the div of those two things. So let's go ahead and say that div 1 equals 2 dot format a b a div b, right? So we're going to print out the results of the div. Lastly, we're going to do the a mod b. So this way. Okay. And lastly, one thing I want to do is check and make sure that this equation is indeed being satisfied. So I'm going to print out, is A equal to, well, it should be equal to B times A div B plus A mod B. I don't have to put parentheses around this. This has higher precedence than the plus. But if you prefer, there's no harm in putting extra parentheses. So we can put it in. Okay, so let's take a look at our results. And of course, I have to close off the print statement. So there we go. All right, so 13 divided by 4 is 3.25. That was a float. 13 div 4 was 3, the floor of that. 13 mod 4 is 1. And that equation is satisfied. You can see that it returns true. So A is indeed equal to this whole expression here. Now let's go ahead and do this as well for negative numbers. So let's take A equal to -13 and B equal to 4. So we're going to run through the same examples that we had in the slides. And as you can see, we get -3.25 for the division, -4 for the floor division, 3 for the mod, and that equation is satisfied. So I just want to basically go through and make sure that the equation is satisfied in every instance. So again, we'll copy paste that. And we'll stick the negative on the 4 this time. We'll leave the positive 13 alone. Run that. And as you can see, our equation evaluated to true. So again, that worked. And let's do one more, where we're going to set both A and B to negative. And when we run that, well, again, we get that the equation evaluated to true, right? So in other words, that equation was valid. So that expression evaluated to true, which means that the equation, and this is the last time I'll mention it in this video, this equation here was indeed valid. All right, thanks for watching, and I'll see you in the next video.